You type one line. The model moves to the GPU. No driver ceremony, no weekend lost inside a dependency tree. It just runs. I know, it looks harmless. But that tiny command sits on top of a decision Nvidia made almost 20 years ago, when artificial intelligence was still a side project for most of the industry. Not a new graphics card, not more memory, a software platform. That is how CUDA made Nvidia almost impossible to replace. The simple version says Nvidia won AI because its GPUs were fast. Fine, fast hardware mattered, but faster chips appear every year. CUDA did something slower and more valuable. It gave developers a stable place to build code, tools, libraries, research, production systems, and eventually entire careers. Once enough of that work accumulated, changing the chip meant changing everything around it. The GPU did the math. CUDA made the math portable across Nvidia's future. Before CUDA, researchers already knew GPUs could do more than draw games. A graphics processor repeats similar operations across huge blocks of data: pixels, vertices, lighting.
That same parallel structure is useful in simulations, image processing, and scientific computing. So researchers started using graphics cards as cheap mathematical engines. The problem was access. The hardware spoke graphics. If your data was not an image, you often had to dress it like one. Numbers became textures. Calculations became rendering tricks. A scientist studying proteins could end up writing code like someone trying to make realistic water in a video game. Clever. Also miserable. In Stanford, Ian Buck and other researchers built Brook for GPUs, a C-like system for general-purpose computing on graphics hardware. Brook showed that some ordinary workloads could run far faster on a GPU than on a CPU. Nvidia hired Buck. Then came the move that changed the business. Instead of leaving general-purpose GPU computing in the research lab, Nvidia built it into the product. CUDA arrived in late 2006 with a programming model, compiler, runtime, tools, and a direct route to the GPU. You no longer had to pretend your matrix was a very ugly picture. In theory, the market should have stayed simple. Nvidia creates CUDA. Competitors create alternatives.
Everyone fights over speed and price. But hardware and software age differently. A chip can be copied, undercut, or beaten. A mature software stack has to be grown. Therefore, every year Nvidia improved CUDA, the contest moved farther away from the silicon itself. Compilers, debuggers, drivers, math libraries, documentation, sample code, forum posts written by some exhausted engineer who already found the bug ruining your afternoon. And Nvidia made CUDA available on consumer GeForce cards, not only expensive scientific machines. That mattered. A student could learn on a gaming PC, publish research, join a startup, and keep using the same platform in a data center. This was not an obvious use of company time. Nvidia's main business was still graphics. CUDA needed compiler engineers, documentation, developer support, and hardware changes long before AI revenue could justify any of it. Most customers were buying cards to render games, not to train neural networks. So the company kept funding a platform for users who looked small on a quarterly chart. That is the part I respect.
The software ecosystem is useless if the vendor treats it like a temporary experiment. Developers had to believe code written today would still matter after the next GPU launch. CUDA was useful without being dominant. It found work in physics, medical imaging, finance, molecular simulation, and supercomputing. Good markets. Serious markets, still not the reason Nvidia would become the company supplying the engines of the AI boom. Then neural networks became larger, datasets became heavier, and training demanded huge amounts of matrix multiplication and convolution. Exactly the kind of work GPUs handled well. In 2012, AlexNet made the advantage visible. AlexNet entered the ImageNet competition and reached a top 5 error rate of 15.3%. The runner-up was at 26.2%. The network trained for 5 to 6 days on 2 Nvidia GTX 580 cards, each with 3 gigabytes of memory. 2 gaming cards. One result that changed machine learning. Now look at the evidence like an engineer, not a keynote audience. Was the breakthrough only the GPU? No. Parallel hardware already existed. Neural network research already existed.
The useful question is why a team could obtain the hardware, program it, optimize the workload, and repeat the experiment without building a custom supercomputer first. Nvidia had spent 6 years making that possible. AlexNet did not create CUDA's advantage, it revealed it. Then Nvidia removed another layer of pain. In 2014, it released cuDNN, a library of optimized operations for deep neural networks. Before cuDNN, squeezing performance from a GPU could require specialists to hand-write low-level kernels. After it, framework developers could call tested routines for common neural network operations. Nvidia's engineers handled more of the hardware-specific optimization. Researchers worked higher in the stack. The clever part was not simply releasing another library, it was deciding where the difficult work should live. If every research team had to optimize the same convolution operations for every new GPU, progress would stay slow and fragile. By putting those routines inside cuDNN, Nvidia could improve the performance centrally. A framework update could then deliver those gains to thousands of projects without every team becoming a GPU architecture specialist. One engineering team did the painful optimization once. Everyone else inherited it.
That was the moment CUDA stopped looking like a feature and started behaving like infrastructure. CUDA at the bottom, libraries such as cuBLOS and cuDNN above it, then Caffe, TensorFlow, and PyTorch, then cloud providers, then university courses asking for experience with the same tools. Follow the loop. Developers choose CUDA because their framework supports it. Frameworks prioritize CUDA because developers use it. Cloud providers buy Nvidia systems because customers request them. Customers request them because their code already runs there. Nobody planned the entire structure from one boardroom. It formed one practical decision at a time. Could another company build a powerful accelerator? Yes. Could it win a benchmark? Also yes. But a benchmark does not migrate a production system. It does not rewrite custom kernels. It does not retrain the team. It does not reproduce numerical behavior, replace debugging tools, or guarantee that the obscure operation needed by one model will work at 2 in the morning. That is what the usual hardware comparison misses. The rival is not competing with one GPU. It is competing with every solved problem around that GPU.
People call this vendor lock-in. The label fits, but it can make the process sound more dramatic than it was. Most teams did not choose CUDA because an executive signed a blood contract with Nvidia. They chose it because the framework worked there first. The documentation was better. Someone on the team knew it. The cloud instance was available. The deadline was Friday. Reasonable choices, repeated for years. That is how convenience became dependency. Nvidia could release a new GPU and inherit the software built for the previous ones. A rival could release excellent hardware and begin the sales pitch with a migration project. Very inspiring. CUDA is not magic, and Nvidia did not create the AI boom alone. Algorithms mattered, datasets mattered, semiconductor manufacturing mattered, open research mattered, cloud infrastructure mattered. Alternatives exist. AMD has ROCm. Google, Amazon, Intel, and others have their own accelerators and software stacks. Higher-level compilers are improving. Specialized chips can be better for specific workloads. The compute gap can close. The workflow gap is harder, because the real product is not only the processor. It is the expectation that the project will run, the tools will exist, the team will understand them, and the next hardware generation will not force a rewrite of the company's technical foundation. So look at that tiny command again. It moves a model to the GPU.
It also chooses the libraries already optimized, the tutorials already written, the cloud machines already installed, and the engineers already trained. Nvidia became the default for AI because every successful CUDA project made the next CUDA project easier to justify. The company sold the engine, then spent years building the roads around it. A competitor can arrive with a better engine. Fine, the roads are still Nvidia's. That is the part worth remembering. The easiest line in your project may be the hardest dependency to remove. Which technology platform should I put on the autopsy table next? Leave the one your team could not replace without starting a small internal civil war.